All right, we are going to talk about exponent rules. So hopefully you've learned these rules, but let's refresh. Any base to the power of 0 is always 1. Always, always, always. Any base to a negative power can be rewritten as 1 over the base to a positive power. So to get rid of a negative exponent, moving the base and the exponent across the fraction line is how we do it. So x to the negative 5th power is actually 1 over x to the 5th power. So let's simplify these. 10 to the 0 power. Anything to the 0 power is 1. 3x to the 0 power. Remember that's 3 times x to the 0 power. Well, x to the 0 power is 1, so it's 3 times 1, which is just 3. X to the negative 2nd power, I take my negative power, drop it to the bottom, and make it positive. For 5x to the negative 6th power, the x is the only thing with a negative power, so only the x moves to the denominator, and the exponent becomes positive. For 12x to the negative 3rd power, the 12 stays in the numerator. The x moves to the denominator, and the exponent becomes positive. And for 15x to the 0 power, remember x to the 0 power is 1, so 15 times 1 is just 15. All right, some more properties of exponents. B to the n power times b to the m power. So if I have the same base and I'm multiplying them, I just add the exponents together. B to the n power divided by b to the m power is b to the n minus m power. If the bases are the same and you're dividing, you just subtract the exponents. B to the n power to the m power, a power to a power, you multiply the exponents, b to the n times m power. If I have two things multiplied, a times b, and they are raised to a power, I can distribute the power, a to the m power times b to the m power. And if I have a fraction, two things divided, raised to a power, I can distribute the power there too, a to the m power divided by b to the m power. Remember that you can distribute an exponent into multiplication and division, but you can never ever distribute an exponent into adding and subtracting. And then we also talk about changing a radical to an exponent. So the nth root of something is that thing to the 1 over n power. So a root can always be written as a 1 over that power. And so the nth root of a to the m power, the exponent is m, so that becomes the numerator of the exponent. The root becomes the denominator of the exponent. So now let's try some problems. 4x squared y to the negative 3rd times 3y to the negative 4th power. We want to write our answer with only positive exponents. So I'm going to rewrite it. Right away, I'm going to move the y's to the denominator. So I have 4x squared times 3 over y to the 3rd times y to the 4th. Remember, the exponents become positive when they drop to the denominator. Well, 4x squared times 3 is 12x squared. And y cubed times y to the 4th, I've got the same base. I add the exponents, making it y to the 7th power. For number 2 here, my x has to move to the denominator. This y has to move to the denominator. So I have 3x cubed over x cubed times y to the 1st power. Well, I have x cubed over x cubed. Same base, subtract the exponents. I get x to the 0 power. So I have 3x to the 0 power over y to the 1st power, which is just y. Remember, anything to the 0 power is just 1, so really I just end up with 3 over y. 4a squared to the 4th power. Well, I can distribute a power into multiplication, so I take 4 to the 4th power times a squared to the 4th power. Well, 4 to the 4th power is just a number. It is 256. A squared to the 4th power, a power to a power I multiply, so it's a to the 8th power. Remember that my base stays the same, only the exponent changes. Next up, I can distribute my power of 3. So I have x to the 4th power cubed times y squared cubed. Well, x to the 4th power cubed, power to a power, I multiply my exponents, making it x to the 12th power. Power to a power makes it y to the 6th power. All right, for number 5 here, we're going to think of this in separate pieces. So my first piece is 4 over 2. Well, 4 over 2 is just 2. I have a v in the numerator and a v squared in the denominator. I subtract those exponents. 1 minus 2 is a negative first power. Same thing with my u's. U to the fourth minus 4 becomes u to the 0 power. Well, a u to the 0 power is just a 1. A v to the negative first power drops it to the denominator. The 2 stays in the numerator. My answer is 2 over v. Next up, my 2 and my 3 don't simplify, so I leave it as a 2 over 3. My a, there's only 1 in the denominator, so it's going to stay in the denominator. For my b's, I have b squared over b to the 4th power, so I'm going to make that a b to the negative 2nd power because 2 minus 4 is negative 2. Now that does need to drop into the denominator to become a positive exponent. So it's 2 over 3a to the 4th power, b to the 2nd power. So remember, when I subtract those exponents, that automatically moves it to the numerator. Then I take that negative power, drop it to the denominator. All right, for number 7 here, x to the 0 power is just 1 to the 4th power times 2x cubed y squared. And 1 to the 4th power is just 1. And 1 times anything is just what else I have. So 2x cubed y squared is my final answer. All right, for my next one, I would start by distributing that 4th power. So my 2x to the 4th, y to the 4th is going to hang out. And I get 2 to the 4th power, which is 16. X to the 4th power. And then my y is a power to a power, so it becomes y to the negative 8th power. Now I'm multiplying, so I'm going to take 2 times 16. I'm going to take my x to the 4th times x to the 4th. And I'm going to take my y to the 4th times y to the negative 8th. Before I move anything to the denominator, I'm going to do this. So 2 times 16 is 32. X to the 4th times x to the 4th. I add my exponents, making it x to the 8th. Y to the 4th times y to the negative 8th. I add the exponents, making it y to the negative 4th. Now I have to move that y to the negative 4th to the denominator. So my 32x to the 8th power stays in the numerator. My y moves to the denominator, becoming a positive 4th power. All right, for number 9 here, I would personally start by distributing that 4th power. I could start by simplifying the inside. I'm just going to distribute the 4th power to everything. So x cubed to the 4th power becomes x to the 12th power, because power to a power I multiply. Y cubed to the 4th power becomes y to the 12th power. 2 to the 4th power becomes 16. X to the 4th power, boom. Y squared to the 4th power becomes y to the 8th power. And x squared to the 4th power becomes x to the 8th power. Now in my denominator, notice I have an x to the 4th and an x to the 8th. So I would actually combine those before I do anything else and make it x to the 12th power, y to the 8th power. Now my x's, I have x to the 12th power and x to the 12th power in the top and the bottom. That makes an x to the 0 power. That makes a 1. I don't need to worry about it. My y to the 12th power and y to the 8th power, I subtract those exponents, making it a y to the 4th power. And that's in the top, and my 16 is still hanging out in the denominator. All right, for number 10, I would start it out the same way. I'm going to distribute this power of 3. It makes it a to the 3rd power, b to the negative 6th power, a to the negative 6th power, b to the negative 6th power, over 8b to the negative 12th power. Well, I have negatives within my fraction, but that's fine. We'll deal with it in a second. Let's combine our a's and b's in the numerator. A cubed times a to the negative 6th power is a to the negative 3rd. B to the negative 6th times b to the negative 6th is b to the negative 12th. Over 8b to the negative 12th. Well, notice that my b's, negative 12 minus negative 12 is 0. Those cancel out. My a to the negative 3rd power has to drop to the denominator with my 8. So what's my new numerator? Just a 1. And for 11, I just want to rewrite this with a rational exponent. A square root is the same thing as saying the inside to the 1/2 power. A cube root is saying the inside to the 1/3 power. And 2 more problems for us to simplify here. I'm going to start with these outside powers. So this y cubed is going to hang out for a second. X cubed to the -1st power is x to the -3rd power. 2 to the -2nd power, we'll call it 2 to the -2nd, y to the -2nd power, and x to the -2nd power to the -2nd power becomes x to the 4th power. Let's combine my like terms that are in the denominator here. Or not like terms, but my common bases. We'll keep my 2 to the -2nd power. X to the -3rd power, x to the 4th power becomes x to the 1st power, and my y to the -2nd power. Now I'm going to move this 2 to the -2nd power to the numerator. Because usually I'd move it to the denominator, but it's already in the denominator, so that moves it to the numerator. My y cubed is still up in the numerator, and this y to the -2nd can actually jump up there as well and become y to the +2nd, keeping just my x in the denominator. Now I know 2 squared is 4, and y cubed times y squared becomes y to the 5th power over x. And finally, number 14 here, we are going to do the same thing. We'll call it 2 to the -1st power, x to the +3rd power, y to the -4th power over 2xy cubed. Well, this 2 to the -1st power can drop down to the denominator. This y to the -4th power can drop to the denominator, leaving just an x cubed in the numerator. I have 2 to the 1st power times 2 to the 1st power times x times y cubed times y to the +4th power. Well, I have an x cubed over x to the 1st power. Subtract those exponents, I have an x squared left. I have 2 times 2, which is 4. And I add my bases, or add my exponents for my y's, making it y to the 7th power as my final answer.